Today, we'll discuss a model designed to explore the influence of circular business model design on its viability. This model, set within an industrial symbiosis network, simulates how a processor uses organic waste from suppliers to produce biogas and, I mean, nutrient-rich digestate for local use. Viability in this context is measured by value captured, such as, cash flow per ton of waste per agent, and the survival of the network over time. So, before diving in, could you please introduce yourself?
Yes, my name is Caspar Lange. I'm an associate professor at the Amsterdam University of Applied Sciences, and I have built this model together with colleagues at Delft University of Technology in the Netherlands.
To start, could you explain the, main purpose of this model and what inspired its development, especially in relation to circular business models and industrial symbiosis networks?
Yes, so we were researching the phenomenon of eco-industrial parks and industrial symbiosis networks, which are networks of companies that aim to reuse each other's waste streams or residual streams as a resource for production. And this has to do, of course, with aims on sustainability and circularity, especially in the Netherlands and Europe. This is a huge topic, but also trying to find ways to create competitive advantage by using residual waste streams. And yeah, we came across the problem that many companies are hesitant to do investments because, yeah, this takes a lot of time to set it up, lots of high investments. A biodigester is, well, for some of these small and medium-sized enterprises, pretty expensive. So we wanted to find out if we could test certain circular business models before actually investing and implementing the technology. And we decided to then also extend our model towards multiple design choices and options, and see which configurations of circular business models or and designs would yeah, likely be the best options to also make money. And the best option to yeah, create a network that is robust, and which means that the companies will yeah, remain within the network and also stay willing to exchange waste streams for production of biogas and digestate.
What were the key challenges you encountered while, developing this model? Were there any specific difficulties in simulating the dynamics of value capture or, modeling actor behavior, especially in terms of waste supply fluctuations and economic benefits?
Yeah, so the main challenge was actually creating a model that was remained relevant to all the participants. We encountered many different perspectives and aims within the symbiosis network. Actually, the companies were a network already, but they weren't exchanging waste streams yet. So they had a mutual aim to create such a network, but they all had different subtopics that they wanted to explore. So one of the main challenges was to make sure that the model remained relevant, and we did so by yeah, participatory modeling and validation efforts.
Now, let's talk about the findings. What are the main insights you have gathered from running the model? Have any patterns emerged in terms of the survival of the network or sustainability of circular business models?
Yes, so we discovered, our model was mainly used to measure the survival of the network and indeed the value capture, as you mentioned. And we saw, for example, that when we tested two scenarios, one in which the waste that wasn't used in our network that was disposed of towards an external party for incineration of the waste, that if that contract with an external incinerator would be paid per month, that would lead actually to a lower survival rate of our symbiosis network than if the incinerator would be paid per ton waste. So that means that not only the business model and the organizational decisions within our symbiosis network are relevant, but also the contracts with the original contracting company are relevant. So we discovered that the environment was very much influencing the success rate of our symbiosis network. Another thing we discovered was that we could play with the 20 design options within our circular business models, and we found that certain combinations of design options resulted in higher survival rates, but also in higher value captured. So, for example, if companies were able to increase their gas production per mass unit of waste by putting effort in educating their operators, for example, then that would increase the survival rate, and also increase the revenues created from the biogas sales. But we also found that other types of variables could be optimized. So, for example, if you would share the revenues that come from selling biogas to companies, then there would be an optimum somewhere in the middle of our inputs. So that means that you can try and explore and find out which combinations of design options would result in the highest chance of survival and also in the highest value capture. Yeah.
You have made your model available on comsys.net. What challenges did you face in making it, accessible and available for others on this platform? And how did you ensure that it was well documented and easy for users to understand and of course replicate?
Yeah, so indeed, because of the complexity of the model, it was quite hard to make it understandable to others. And this is actually the main reason why we chose ComSys, because of the service of the peer review. So we could see if it was actually understood by the peers during the process of publishing. And this also resulted in some comments on the ODD description, for example. So we were allowed to improve that, and it was really helpful to create an ODD description that was more was better at communicating the model mechanisms and purpose, etc., to the audience. So. In addition, we also created flowcharts to help people that are more visually oriented to understand the model. So our model, for example, is built up in several modules that are used depending on the decisions of the agents. So every module has its own flowchart, which makes it yeah, hopefully easier for the audience to understand what happens, but also for yeah, potential users of the model to yeah, build further upon the model. So you can actually build additional sub-modules to create extra yeah, business models, for example, or other scenarios. Yeah, I think this is very nice that we were able to provide all this information on ComSys. And the other thing is that it's nice that ComSys provides a DOI, so we could link it to our research paper in a journal. Yeah, we could also tell the journal editor that this model was also peer reviewed already, so that makes it stronger and yeah, more transparent.
Finally, what's next for this model? Are there any follow-up research or updates planned to further explore the viability of circular business models, or address the different aspects of industrial symbiosis networks?
Mm-hmm. Yeah, certainly we are working on new models. For example, similar cases at eco-industrial parks to further validate our model, or even extend it to other circular and regenerative business models. For example, we are looking at symbiotic networks that are trying to create circular business models with materials in the technosphere. For example, machine builders. And we also look at symbiotic networks at multiple scale levels. So not only at the eco-industrial park, but also on regional level. One other thing is that we are also improving our participatory methods as a way to, yeah, create data and information for modeling.
Thank you very much for joining me and sharing your insights on this model.
You're welcome.